Okay, this is another family of organic chemistry molecules, the carboxylic acids, and you can see the functional group here. So I've written the first four members, and they all share this functional group here. So it's a carbon with a double bond oxygen and an OH on it. Okay, that's the carboxylic acid group. And you may think, oh well, alcohols also have an OH group, which they do. So why aren't these alcohols? Well, the OH group is the behavior. It's modified quite a lot by having this carbon oxygen double bond next to it, sufficiently so that they are pretty different to the alcohols and they're their own group. Okay, so how do we name them? Well, we call them the first one in the series, which I always think looks a bit odd because is methanoic acid, because it's just got that hydrogen attached to the carbon. Methanoic acid, and then we've got ethanoic acid, which is if you smell that, you'll say, oh, it smells of vinegar, because vinegar is a dilute solution of ethanoic acid in water. And then we've got propanoic acid with 3 carbons, and butanoic acid with 4 carbons. Now let's talk about that. How that having the carboxylic acid group affects their physical properties. Well, if you think of the corresponding alkane to methanoic acid, it's methane with 1 carbon, that's a gas at room temperature. Whereas methanoic acid has got a boiling point of about 70 degrees C or something like that. I think it's definitely a liquid. So having the carboxylic acid group, and the others, all 4 of them, they're all liquids. Having the carboxylic acid group makes the boiling point a lot higher. Also, you remember that alkanes will not mix with water. So if you get like a big alkane like C8H18, which is a liquid present in petrol, that will not mix with water. You just form 2 layers. Whereas all the carboxylic acids, they will mix with water. And that gets on to why they're called acids, because when you mix them with water, they'll dissolve in water and they'll form acidic solutions. Okay, so pH less than 7. So let's have a look at a little bit more detail about it. They're not what you call strong acids, they are weak acids. So look, I've got 2 bottles of acid there. Both have got the same concentration, 1 mole per decimeter cubed. Hydrochloric acid, which is a strong acid, and 1 mole per decimeter cubed ethanoic acid, that's a weak acid. But if you look at the pHs of them, well, hydrochloric acid has got a pH that will have a pH of 1, whereas ethanoic acid won't be as acidic, more like pH 3. Okay, so what do these terms strong and weak mean? Well, it doesn't mean concentrated and dilute, because obviously those both acids have both got the same concentration. It's something a bit different. And there is a separate video describing strong and weak acids, if you want to look at that. We'll just briefly explain it here. But here we've got, well, let's think about, what do we say an acid? An acid is a substance which makes H+ ions in solution. Okay, so we can see, all right, hydrochloric acid. So this is covalent hydrochloric acid, a covalent molecule, and that bond breaks there, and it gives a chloride ion and a hydrogen ion. Now, hydrochloric acid is a strong acid, so 100% of the hydrochloric acid molecules will dissociate. In other words, turn into ions. Right, let's look at ethanoic acid, which we've got down here. Now, it makes hydrogen ions in solution, but it's always this hydrogen that comes off and forms a hydrogen ion. The other ones don't, okay? And what happens is that bond there breaks. Both of the electrons are kept by the oxygen, so you form a negative ion here, the ethanoate ion, that would be called. Don't worry what it's called. And hydrogen ion, which makes it acidic. Now, it's only a small proportion which actually dissociate. Most of the ethanoic acid molecules just stay as this. They don't turn, they don't make the hydrogen ion. So that is why ethanoic acid is a weak acid. So of course, if you get 1 mole per decimeter cubed, like we've got here, of both acids, okay, so you've got, that's the concentration. Well, the the HCl, all of it dissociates, so the hydrogen ion concentration will be pretty high. It'll be like 1 mole per decimeter cubed. Whereas here, it's only a small proportion. It's got a low hydrogen ion concentration. And if you remember, the pH scale is a logarithmic scale. So when you go from, if you go from pH 1 to pH 2, in the pH 1, you've got 10 times higher H plus ion concentration. And likewise, if you go from pH 1 to pH 3, well, that's 2 units. Well, it's 10 squared times higher. In other words, that's 100 times higher hydrogen ion concentration. And if you did 3 units, it'd be 10 to the power of 3, 1,000 times, and so on. So you may think, oh, there's not much difference between pH 1 and pH 3, but there's a 100-fold difference in the hydrogen ion concentration. Okay. Now, it's hydrogen ions, that is what makes acid acidic, and that makes the acid do the things that acid do, like they will dissolve magnesium ribbon, they will react with carbonates, and so on. And so on. Right, so now let's just see, in the specification it says you need to know how ethanoic acid reacts with carbonates. So let's just go back to a strong acid. Okay, when we add an acid and a carbonate here, so I've got calcium carbonate in this first example, reacting with a strong acid, hydrochloric acid. It gives you calcium chloride and it gives you CO2 gas, so it will fizz. You always get fizzing. So if you get a piece of solid calcium carbonate and hydrochloric acid, it will fizz up and it will dissolve. This calcium chloride solution is an aqueous solution. Yep. Likewise, if you get sodium carbonate, so a different compound behaves in a very similar way because it's got the carbonate. And so react that with sulfuric acid instead of hydrochloric acid, well, you get a different compound, you get different salt, you get sodium sulfate, but you do get carbon dioxide gas again, so it will fizz. So you always get fizzing. So let's see what happens if you put some carbonate into ethanoic acid then. Right, so we're going to put a piece of calcium carbonate in there. There's a piece of solid calcium carbonate. If you put in the hydrochloric acid, it's going to fizz pretty quickly. You get lots and lots of bubbles. And it will dissolve fairly rapidly. Okay, and of course the bubbles are carbon dioxide. Whereas if you look, let's put a piece in ethanoic acid. Now, remember the hydrogen ion concentration in ethanoic acid, even though the acid is the same strength, the H plus concentration is lower. So you get a fairly slow rate of bubbling. But it is producing CO2, but it would take a long time for the piece of calcium carbonate to dissolve. So there we have carboxylic acids, called acids because they make acidic solutions. Okay, now in the next video, we're going to talk about how carboxylic acids react with alcohols to form another kind of substance called esters, which smell fruity, but that's a little bit complicated and make the video too long, so we're going to stop there now. Okay, Luna, stop moaning.